Hi, hello everyone. So this is the video dealing with section 4.2, trigonometric functions from the unit circle. And this is the second part where we're going to link the fact dealing with the movement on the unit circle with the functions that it produces. So as we mentioned before, when we have a unit circle, okay. Unit circle meaning the radius from the origin to the edge is 1 unit. As an angle increases, it produces a location on the circle, and we have the y and the x component associated with the sine of the angle and the x with the cosine of the angle. Now, and then we mentioned that out of these two functions, we are able to produce four more. Okay, so instead of now, in the first part of the video, we gave you the 6 function definitions in terms of the x and y coordinates along the unit circle. And now we show you the relationship with the functions themselves. Okay, so provided that we know sine and cosine, which is the position on a particular point moving along the unit circle, we have the tangent is sine of t over cosine of t instead of y over x. Cotangent is cosine of t over sine of t instead of x over y. And then we have the reciprocal identities. These are the main ones. We usually don't redefine sine, cosine, and tangent. Cosecant instead of 1 over y is 1 over sine t. Secant is 1 over cosine t instead of 1 over x. And cotangent t is 1 over tangent instead of the usual x over y. Okay, in addition to those basic identities, we have the Pythagorean identities, which we can see from the triangle formed on the unit circle. So here's my angle, and here's the triangle. This is always 90 degrees. All right, here's the point, and this arc here is always a unit 1 because it's the radius. This is y, and this is x, and here's my triangle. So the triangle identities that form are here. Sine squared t plus cosine squared t equals 1. 1 plus tangent squared t equals secant squared t, which is obtained by dividing everything here by sine squared t. And then the last one was 1 plus cotangent squared t equals cosecant squared t. Now, let me just mention one thing, because this is a common mistake when students are working with these identities. Now, sine squared t is equal to sine of t times sine of t, which is not the same as sine of t squared. All right. This means the function getting square. So this is the function square, whereas this is the angle square. Okay, so do not make a mistake. And you can test this. I'm not going to test it now, but for example, you can let t equals 30 degrees and then evaluate sine of 30 degrees, which is 1/2, sine of 30 degrees, which is 1/2. And if t is 30 degrees, then you have sine of 30 square, which is sine of 900 degrees, and see if this is equal to sine of 30 times sine of 30. Obviously, it's not. Okay, so don't make that mistake. All of these functions here are the function square, not the angle square. Okay, so later in the course, we're going to talk about specific formulas for double angle and half angle, and you see that this is the case. All right, so we have these identities. The main ones are here. All right, so the main ones are the tangent t, the cotangent, cosecant, secant, and I have another one for cotangent. Okay, usually we use the Pythagorean identities, but not as much as the other ones. So let's take a look at typical problems on this section, which is very, very similar to the ones before. Let me make it visible so that you can see the identities as we work on them. But now, instead of giving you a point, X and Y on the unit circle, we are going to give you the value of sine and cosine, for example. So here's example 5 and 6, which are taken from the textbook, and you can see the details later if you want to. But so here's example 5. So you are given sine t, you are given cosine of t, and we have to find the other 4 remaining functions. And we're going to use the identities to do so. Okay, so I'm going to do it here. So sine of t is 2/5. Cosine of t is radical 21/5. And immediately I can obviously find tangent of t, which according to the quotient identity there is sine over cosine. So 2/5 over radical 21/5. Now again, multiply by the reciprocal, right? So 5 over radical 21. The 5s will cancel. I end up with 2 over radical 21. That has to be rationalized. No, we cannot leave a radical in the denominator. So this is 2 radical 21 over 21. So this is tangent of t. Now, if we have tangent, we can immediately find cotangent. So cotangent, I can use this definition, or I can use this. So sometimes this definition might be easier. Sometimes this definition might be easier. In this case, the first definition may be easier. And it's okay if you don't see it yet. You can use either one, this or that, and you're going to get to the same result. So I'm going to use cosine over t over sine of t. Okay, so first fraction remains the same. Multiply by the reciprocal. And again, the 5s cancel. And I am left with radical 21 over 2. So that's cotangent. Okay, let's do cosecant. Cosecant t. This is, as you can see there, 1 over sine. And sine is 2/5. So keep the first value, multiply by the reciprocal. And we have 5/2. Let's do secant. Secant of t is 1 over cosine. So 1 over cosine, which is radical 21/5. So again, multiply by the reciprocal. 5 over radical 21. So that is 5 over radical 21. And then I have to rationalize it as I did before. So 5 radical 21 over 21. Okay. So let's see. We already had sine and cosine. Now I have tangent. We have cotangent. We have cosecant, and we have secant. So from the beginning of the sine and cosine that we were given, we were able to, just as before, right, but before we were given a point, we're able to find the 4 remaining trigonometric functions. So this is pretty much the same thing, but now information is given to us in terms of functions. So let's take a look at example 6. It's slightly different. I'm going to erase this. Obviously, if you want to stop the video and take a look at the details, you can to go a little bit slower. So here's the next question. So now you are given that sine of t is 3/5. And you are given the location of the angle, and we have to find, let's say, cosine of t. So this is a very good question. It's a bit typical question. So first of all, I have to know where the angle is. All right, so here's my unit circle. And I was told that the angle is less than 90 degrees and greater than or equal to 0. So which quadrant is this? Well, bigger than or equal to 0, less than 90 is obviously on the first quadrant here somewhere. So here's my angle. So in this quadrant, sine is positive and cosine is positive. In the second quadrant, this is the second quadrant, sine is positive, and as you can see here, right, cosine is negative. In the third quadrant, both sine and cosine are negative, and in the fourth quadrant, I have that sine is negative and cosine is positive. Now, so remember, the sine is the y coordinate and x is the cosine. So from knowing just sine and cosine with the identities, I can find the sign, I can find the value positive or negative for each of the other four identities. So I only have to really know this unit circle. I don't have to memorize anything else to find the value of these identities as to the fact that if they're positive or negative. All right, so let's go back to the problem. Now I know the positive or negative in each case. Again, my angle is in the first quadrant, so I know that both sine and cosine are positive. So I was given sine, and I need to know cosine. So I'm going to write the little small triangle that we get. So it's going to be a triangle. You can see that from the picture, right? So here's the triangle. Okay, so here's the triangle. And so here's my angle T. Here is the radius 1. Now I'm told the sine is 3/5. So this location here, which is x and y, this length is my y, which happens to be the sine of t. And this I know the y coordinate is 3/5. The x coordinate is this length right here, which I don't know. But I know that this is a right triangle. So I have one, I have 3/5. How do I find x? Well, we're going to use the Pythagorean theorem. That's right, which is, right, hypotenuse square equals the square of one of the sides plus the square of the other side. So I know what the hypotenuse is 1 square. One of the sides is x, so x squared plus the 3/5 square. And now all I have to do is solve this equation. So this is 1 x squared. 3/5 squared is 9/25. I'm going to subtract 9/25 from both sides. And I'm going to end up with 1 minus 9/25. Oops. 9/25 equals x squared. I'm going to find a common denominator here, which is obviously 25. So this is going to be 25/25, right? Common denominator. So 25 minus 9, 16/25. And at this point, I will take the square root of both sides. In here, I get 4/5, and on the other side, I obviously get x. So x is 4/5. Now, from the definition that you've seen in the first part of the video, the x is also your cosine of t. So when we found x, we found cosine of t. Now, the question was just find the cosine, but they could have asked the exact same question as before. Find the other four trigonometric, in addition to cosine, find the other four trigonometric identities, right? Which is tangent, cotangent, cosecant, secant. So we could have done that. I'm not doing it now because we've done it before with example 5, but it's exactly the same thing. Okay, so in this case, we had to use the Pythagorean identity. All right, very good. So let's take a look at the last example. I'm going to erase this. So the last example, it's a variation of example 6, but in this case, they give us cosine of t, which is negative 1 over 5, and they tell us this information about the angle. So this is 180 degrees, pi radians, and this is 90 degrees. So our angle is between the first and, I'm sorry, it's after the first quadrant and before the third. So it's in the second quadrant. So our angle, so here is 90 degrees. Here is 180 degrees. So our angle is here. Okay, so obviously, this is my triangle. This is my x. And this is my y. You can see the x is negative, right? Because it's to the left of the origin. But the y is positive. So this is the second quadrant. So my angle is in the second quadrant. So we are asked to find tangent of t. So I'm going to expand this triangle right here. So here's the triangle. Again, this is the radius 1. This is y. And x, I know they gave us cosine, which is, the cosine is negative 1/2, but the length of this side is obviously positive, which is 1/2. So again, how do I find tangent? Well, before I find tangent, I have to find sine, which is this y. So y is my sine of t. Well, I know how to find y, which is using the Pythagorean theorem. So I'm going to do the exact same thing again. So 1 square equals to y square plus 1/2 square. Okay, that's the Pythagorean theorem. So 1 equals y squared plus 1 over 4. I'm going to subtract 1/4 from both sides. And I am going to get y squared equals 1 minus 1/4. I'm going to find a common denominator, which is 4. And I'm going to adjust the numerator, which is 4 over 4. So now I have 4 over 4 minus 1/4 is obviously 3/4. And now I will take the square root of both sides. On the left, I get y. On the right, I get radical 3 over 4, but I have to break it into two parts because I can simplify the radical. You cannot leave the answer this way. Okay, that's not allowed because you can simplify this radical. So this will be radical 3 over 2. So my y, or sine of t, is radical 3 over 2. Now, they want us to find tangent. Now, what do? I will use the first quotient identity up here. Tangent of t, sine of t over cosine of t. So that's fairly easy. Tangent of t. I already know what sine of t is, which is my y component, divided by cosine of t, which is negative 1/2. And again, I'm going to multiply by the reciprocal. The 2's cancel, and I get negative radical 3. So my tangent of t is radical 3. And again, if I wanted to find the other identities, I would use the same, I'm sorry, if I wanted to find the other functions, I would use the same identities here: cotangent, cosecant, and secant, the other three. Okay, so this is how you use these identities, the quotient or the reciprocal, to find the value of all trigonometric functions on the unit circle.